All right, so today's lesson, this is part 2 of lesson 7.6, multiplying polynomials. You will need your 7.6 practice worksheet, which can be found under this video in Canvas. Yesterday, we spent some time working on our multiplying binomials. We talked about the FOIL method with the idea that if I take my first, outer, inner, last terms, we can multiply these two expressions together. Now, I will be honest, today is going to be a little bit of a brain cell burner because we are going to have to multiply much larger expressions today than we did yesterday, and they get to be a little intense. So here we can see the solution to the first one, just sort of as a refresher of this idea that we will take together the first terms. We're remembering to multiply when I have a times a and, adding my exponents. And so here we have negative 3ab. This one's a little different. Inner two terms, negative 2ab. This guy, we didn't have one like this before. Outer two terms, negative b times negative b is a positive b squared. So in this one, in 9, you need to watch out the fact that each of the terms inside of each binomial have a letter. And so this one's a little different than number 5 was. And so be careful when you're multiplying. That outer term, that 3a times that negative b gave me negative 3ab. We can multiply unlike things. We just can't add or subtract them. My inner two terms gave me that same idea. Negative b times 2a is negative 2ab. And usually we put our letters in alphabetical order. AB is the same as BA because A times B would give me the same result as B times A. So we usually put them in alphabetical order. That will just make it a lot easier moving forward. These two middle terms are still alike. So I'm going to bring down the 6a squared. Negative 3ab minus 2ab gives me 5 of those. Negative 5ab plus b squared. So it's really important that you pay attention to this one, especially as we start to move forward and prepare for our chapter 8 work. So keep that in mind as we are working forward. Now, if you're looking at your worksheet, you're looking at some that you're saying, oh my gosh, Mrs. Kiskadden, what am I supposed to do here? And so let's take a look at number 11. So today we're really focusing on polynomials times polynomials, not so much a binomial times a binomial, okay? And although I'd love to say that first, outer, inner, last works really well here, that really is just a shortcut for your two binomials, but we're really doing the same thing that we did before. So let's see how to tackle this guy. So the idea, remember, was that we have to take this outer term here, this binomial, I'm going to multiply it by each term inside of the other polynomial, which is what we did with the other one. But what the shortcut says is, hey, if I take this term here, this first term, and I distribute him to each one of the terms inside, it's still giving me that same idea. I mean, I could write this out long, but there isn't enough screen to do that. So this will allow me to do that. So I'm going to distribute that m all the way through. M times m squared is going to give me m cubed. So keep that in mind. This is that m times m squared. Then my next m times 4m, so that m times 4m is going to give me, and they're both positive, a positive 4m squared. First term times the last term, which is the m times the negative 8. It is a negative out there, so that's going to give me a negative 8m. Okay, when I collect that together. So that negative sign gives us our the idea of subtraction. Now, I find the easiest way to do this for the next one is to actually stack them on top of each other when I'm looking at like terms. So I'm going to take this 5 and I'm going to distribute him also across each of the terms. So I have 5 times m squared. Now, because there's no other letter here, I'm going to stack him down here underneath the m squared. It makes it a lot easier if I can stack them together when it comes time to pulling them all together. Then I'm going to distribute that 5 out to the 4m, so here we get a positive 20m. Distribute that 5 all the way out to the negative 8, gives me negative 40. He doesn't have any letters, so you can see here I've stacked them all together, and the idea here is we're going to add them together then. Okay, I could have written this all the way out here at the end. Okay, I could have done this and then used our rules from 7-4, collect them together. But sometimes if I stack them together, it's a lot easier to see that. So I have m cubed. There's no other m cubes, so I have m cubed. I have 4m squared plus 5m squared is 9m squared. I have negative 8 plus 20m, which gives me a positive 12m. And there was nothing else that went with the 40, so I bring down negative 40. That same thing would have happened here. I only had 1 m cubed if I look across the top, so there was only 1 m cubed. Here I can see I have a 4m squared. There was the 5m squared. If I wrote it as one long line, still gave me the 9m squared. Negative 8 plus the 20 gave me the 12, and there was nothing to go with the 40. So you can write it as one long line, as you can see the first example, or you can stack them. I really like stacking them, especially when we get to the two trinomials. It really just helps to keep all that stuff organized. So, but we can see I ended up with a regular polynomial, a 4-term polynomial, okay, where I start with m cubed and write it down to where I have no letters left. Let's try another one. So again, the idea, I'm going to distribute that 2h to each term. 2h times 2h squared is going to give me 4h cubed. 2h times 3h is going to give me a positive 6h squared. 2h times 4 gives me a positive 8h. I encourage the stacking. Again, you don't have to do the stacking. I find that the easiest way to tackle it. And I'm going to distribute that 3, that positive 3 to each of these terms. So 3 times 2h squared gives me 6h squared. So I'm going to stack him. I'm going to stack him underneath here. Positive 6h squared. 3 times 3h gives me 9h. 3 times 4 gives me 12. I can collect them together. I only have 4h cubed. I have 6 plus 6, which is 12h squared. We don't add exponents under addition, guys. 8h plus 9h is 17h. Nothing with the 12. Final answer. Next one's going to be a brain teaser, as I had promised. So let's take a look at the next one. Trinomials. Not any different than what we just did in the last example. The only thing is we have 3 terms to distribute across the second polynomial, not just 2. So let's tackle. So we're going to take that 3c squared, and I'm going to multiply it by each term in the expression. Sorry, I don't have the screen space here. So 3c squared times 2c squared is going to give me 6c to the 4th. C squared times c squared is c to the 4th. 3c squared times c is going to give me 3c cubed. 3 squared times 9 gives me 27c squared. Next term. I change color here so we can make a little sense out of it. So second term, it gets distributed across again to each of the terms here. 2c times 2c squared is going to give me 4c cubed. So I'm going to stack him under the 3c cubed. 2c times c is going to give me a positive 2c squared. 2c times 9 is going to give me a positive 18c. Make sure you're paying attention to the signs. Okay, I'm using the signs as I have them. A positive 2 times a positive 9 gives me a positive 18. Last term, we're going to distribute this guy, and I'm still using the stacking method because I think it's just a little easier. Now be careful, this is a -1 that we're going to distribute to each of the terms. -1 times 2c squared is going to give me a -2c squared. -1 times c is going to give me -1c. -1 times positive 9, sorry, is a -9. I'm going to add this all together. So I'm just going to bring them down through. So there was nothing to join with this guy, so 6c to the 4th. I have 3c cubed and 4c cubed, and they're both positive, so that's going to give me a 7c cubed. I have a positive 27 plus 2, which is a positive 29, but I'm going to subtract 2 from there, so I'm going to stick, these actually canceled each other out right here, so I get a positive 27c squared. Positive 18 minus 1c gives me a positive 17c. Nothing goes with the 9, and so here we go. Wow, we have a polynomial that has a degree of 4. We're going all the way from c to the 4th power, all the way down to not having any c's at all. Let's try one more. I'd pause the video, give 19 a try, and see how it works out when we come back. All right, so let's see how you did. Again, the idea that we're going to distribute that first term to each of the ones inside. So we have 2x squared times 2x squared, which is 4x to the 4th. Pay attention to when we multiply and add our exponents together. 2x squared times -4x is a -8x cubed. 2x squared times 3 gives me a positive 6x squared. So take note, I'm picking up my subtraction and addition signs based on the value that I'm distributing. I'm going to change colors here because I think it makes it easier sometimes. So I'm going to distribute the 2x squared now to each of the terms. Oh, sorry, we did that. 2x times each of the terms here. So -2x times a positive 2x is a -4x to the 3rd. X times x squared is to the 3rd power. -2x times -4x is a positive 8x squared. -2 times 3 is going to give me a -6x. Make sure you're bringing the variables along, because otherwise we end up with things that are not going to look like they are alike, and we're not going to get the right answer. Last one, we're going to distribute that -3 to each of these terms. -3 times 2x squared is going to give me a -6x squared. -3 times -4x gives me a positive 12x. -3 times 3 gives me a -9. It doesn't cancel each other out. This is multiplication, not addition. Okay, so -3 times 3 is a -9. Let's bring it all together. And I could have written this as one long line, but imagine how that would fit on my screen. Not at all. Bring down. So we have 4x to the 4th. -8 and -4 give me a -12x cubed. We don't add exponents under addition. We only did that when we multiplied across. We have 6 plus 8, which is 14. 14 minus 6 is going to give me that 8 again, because those two x's happen to cancel each other out. Don't count on that always. -6 plus 12 is a positive 6x minus 9. Final answer. We're going to try one more. We'll see what we have time for. I have about 50 seconds to get it done. So 1/2 base times height is the formula here. So 1/2 of 2x minus 2 times 4x plus 2. I'm going to take care of the binomial first. First, outer, inner, last gives me 8x squared. Outer gives me plus 4x. Inner gives me negative 8x. Last gives me -4. Collect together 8x squared. Minus 4x minus 4. I need half of that. And we get 4x squared minus 2x minus 2. Homework are the evens 2 through 22. Good luck.